Hello students, I welcome all of you on the fourth chapter, effects of electric current. What are the effects of electric current? Due to electric current, which effects you have found out in electrical gadgets in which you used in everyday's life in your home. Today we have to discuss the energy transfer in an electric circuit. How the energy is transferred in an electric circuit. So this thing we have to study, and after that the heating of electric current. Heating effect of electric current. What is the heating effect of electric current? Which are the effect of electric current we have seen due to heating. So that we have to start with the first thing, energy transfer in an electric circuit. So before we advancing in that point, we have to discuss something regarding with it. In the previous standard, we have already seen that if any substance we have to classify it in it is a best conductor or insulator or semiconductor. What are the parameters? How we have to distribute those substances in a good conductor or a superconductor or maybe semiconductor, or otherwise it is bad conductor or insulator. What are the parameters? Which things which can classify those things that is they are distributed in such like that. In our book they have taken that the iron is good conductor. Already know that iron is good conductor. When we pick up the piece of iron from a ground, we don't feel we could not experience that there should be we have experienced some sort of electric shock is there. Why it happens? Why we could not experience an electric shock when we touches the piece of iron? What is caused behind it? We already know. We have to discuss more thing regarding with it. So that in the next thing we have already seen that the static electricity. Ebonite rod is there, glass rod is there. When we rub this on a particular silky material or anything else, what you have to find out, we have positively charged and negatively charged particles are transfer each other, and the static electricity, the concept from that particular phenomenon is we already saw those things at that time. But here the electricity transfer in an electric circuit. How the electricity transfer in an electric circuit? For that particular thing we have to does this experiment. In that experiment there are lot of gadgets are there. Okay, lot of instruments are there, and these materials which we have used here, this thing we have to discuss in our home. But before that, on page number 47 they have shown the figure number 4.1, effects of electric current. What are the effects of electric current? Electricity there, you know that 182 to 220 volt AC, alternating current. That alternating current is flowing in our electrical wire which is circulating in our home, and we have got 180 volt to 220 volt alternating current. Okay, so what you have to we have to see that the conversion. We know that the law of conservation of energy. This type of electricity converted into different forms. Different form means some sort of a mechanical energy is there in mixer, in the bulb or tubes we can see, or TV we can see the electrical energy is converted into light energy is there, sound energy is there. Okay, in iron is there, or a refrigerator here we can see there is a temperature increase or decreases. Electrical heater, cooker, boiler is there. These are the appliances, home appliances which can convert the electric energy into different way. Okay, so that there are transfer of energy. So we have to today we will study those things. how this energy transferred and how it is proceeds. For that, energy transfer in an electric circuit. Energy transfer in an electric circuit. For that, we have taken, we have drawn on figure 4.2, which is on the page number 48. On page number 48, we can easily see the diagram electric circuit. Electric circuit, here is electric circuit. Is main object, or that means that is material which is used here is a cell. That is positive terminal, that is negative terminal, and this is key which can close or open the electric circuit. After that, here is a resistor. Here is a resistor. Resistor is a device which can resist the electric current, which can oppose the electric current. That is a resistor. After that, here is voltmeter. Here is voltmeter. Voltmeter is a device which can measure the potential drop or potential difference between that particular object. That is a resistor between point A to B. How many potential difference is dropped there in point A and B, which is mentioned by PAB, that is potential difference between point A and B. After that, it is parallel combination. This instrument, that is resistor and voltmeter, we have to always connect a voltmeter in parallel with that particular instrument. Okay. After that, in a series combination, we have to use ammeter. Milliammeter is there. Milliammeter is there used to measure how much amount of current is flowing in the circuit. Okay. The direction of flow from positive to negative. Okay. This is positive terminal, this is negative terminal. This is positive terminal, that means it is high voltage point, and this is negative terminal, that means low voltage point is there. So we have to carry out this experiment. In our book, they have already mentioned that if charge is Q, the amount of charge Q, okay, amount of charge is Q is passing through the point A to B. The amount of charge passing through the point A to B, and after that the total, they have been told us that the work done here, is when transferring this charge from A to B is VAB into Q. This amount of work is done to transfer this charge from A to B. Okay, from A to B. So the question arises here, which provide this energy to carry out this transfer of electric charge from this work? Who carried out this work? And this work is carried by this cell. This electrical cell can provide some sort of energy. This electric cell provides some sort of energy through the charge Q, to the resistance R. The work done, total work done is VAB into Q. Okay. So it is quite clear that in the time t, and the amount of current is I. When amount of current is I flowing in the circuit, the work done here to carry out the charge Q to the point A to B is VAB into Q. Okay. So we have to find out we have seen that the cell can provides the energy. Cell provide the energy to resistor. Cell provide the energy to the resistor to work done to carry out. The amount of work done is VAB into Q to carry out the charge Q from A to B. to carry out the charge Q from A to B, the amount of work done is VAB into Q. At that time, the current in the flowing in the circuit is I, and the time required to circulate the current is T. Okay, so that the main thing here, the amount of energy, the main source of providing this energy to carry out this work to perform a work, we have to require energy. The amount of energy provided, the main source is a cell. The main source is a cell, and cell provides the energy via charge Q from A to B to the resistor. Resistor gains this energy and it can perform this work. To carry out, we can carry the charge from A to B. Okay, so we have to finish this thing. We have to rub this. We have not needed this diagram, so we have to find out what happened next. Okay, after that, we know that power, electric power, okay, and that is equal to power P is equal to, they have been written that energy upon time required, energy upon time. Rate of doing work is a power. Rate of doing work means energy. They are both the interconverted physical quantities, that energy and work done. Okay, so power is equal to energy upon time. So how much amount of energy we have to done there? The energy, that energy is a work done, that VAB into Q upon T. Okay, P is equal to VAB into Q upon T. This is work done, VAB into Q. Q is the amount of charge transfer from point A to B, and so that cell provides energy to carry out this work, and this total amount of work done, that is total amount of energy, is VAB into Q upon time is at that time is T. But we know that Q upon T is equal to I. Q upon T is equal to I. The current is rate of flowing charge. That means rate of flowing charge flowing with respect to time, that is I. So we have to substitute this thing here, and after that we got VAB into I. VAB into I. Okay, VAB into I. So that the equation becomes P is equal to VAB into I. But we know that Ohm's law. But Ohm's law states that, what Ohm's law says, V is equal to IR. V is equal to IR. So we have to substitute. V means VAB. VAB is equal to I into R. I into I in this equation. So P is equal to IR into IR into I. Okay, IR into. So before that, what you have to do? We have to P is equal to Q into Q upon T into I. Okay. So what you have to do? We have to do instead of this thing, what you have to do? The amount of energy which the cell is provided, the amount of energy the cell is provided, this energy is converted into heat. The amount of energy is provided to it. The amount of energy provided to it is converted to the register, is converted into heat, and so that the amount of heat H is equal to the amount of heat H is equal to P into T in time T. Okay, the amount of power, electric power in time T, that much amount of energy we have to utilize, and this energy is converted into heat energy, that P into T. Okay, so here P is here, P is equal to V AB into I into T. Okay, VAB into I into T. But VAB means VAB is equal to IR by Ohm's law. Okay, Ohm's law states that those things. So that what you have to do, H is equal to, we have to substitute VAB is equal to IR in the above equation. So I into R into IT, that H is equal to I into I square R into T, and this is nothing but it is called Joule's law of heating. This H is equal to, this is Joule's law of heating. That much amount of heat we have got when the transfer of Q quantity of charge, coulomb, the charge is measured in coulomb, Q amount of charge, that amount of coulomb charge is transferred from point A to B. When current in the flowing in the circuit is I, for a time T, the value of resistor is R, so that the amount of work done is VAB into amount of work done is VAB into Q. Okay, and after that transformation we have finally got this Joule's law of heating, H is equal to I square RT, and this much amount of that heat energy, that heat is depends upon the radiant heat of the resistor. The resistor radiates heat, it emits a heat. It depends upon, it is directly proportional to the square of current or the resistor, the quantity of resistance of that resistor, or how much time. If we increase the current, the amount of current in the circuit, the amount of heat is greater. Okay, increases by increasing the value of I. If we increase the value of resistor which is connected to it, the point between A and B, the value of R increases, that also increases the amount of heat is radiated by the resistor, or emitted, heat energy emitted by the resistors. And the time, instead of 5 minutes, if we increase the 5 to 10 minutes, that much amount of time which is utilized to produce more energy, that heat energy, and that's why it depends upon time T also. So in this way, Joule's law of heating is finally we deducted the derivation for heating, that much amount of heat we have to got from that. So the unit of electrical power, they have shown what is unit of electric power. What is unit of electric power? Unit of electric power. So unit of electric power, So P is equal to PAB into I. Okay, that means 1 volt into 1 ampere. Okay, 1 volt into 1 ampere. So 1 volt is equal to 1 joule upon 1 coulomb into 1 coulomb upon 1 second. So I just want to mention those things. They have written all this. They have written this explanation in our book. But P is equal to VAB into I. VAB into I means voltage and current. Okay, volt and I. V into I. That means V into I. AB means the potential difference between the point A and B only. This thing can mention only that the potential difference between that particular point, between that electrical instrument component, that is resistor, which is used there, and so that they have written that VAB into I, that means volt into ampere. Volt into ampere. Voltage is potential difference is measured in volt and current in ampere. So 1 volt into 1 ampere. So here 1 volt is equal to 1 joule upon 1 coulomb. 1 joule upon 1 coulomb into 1 ampere. 1 coulomb upon 1 second. That means the charge per unit time. Charge per unit time, it is called current, and the amount of work done per unit charge is called a potential difference. The amount of work done per unit charge is called potential difference. The amount of current flowing in the circuit per second is called the current. So that 1 coulomb get cancelled. We got P is equal to 1 joule upon 1 second. That is 1 joule per second. And that is nothing but joule per second is watt. That the amount of power, James Watt, we already studied the power of steam. In the fourth standard, we have already seen that how much amount of power they have in the steam. So that James Watt in the on this name they have put this unit joule per second, that is a watt. So that the unit of power, electric power, is watt. So we already know that 746 watt is equal to 1 horsepower. So that after studying those things, the next topic which we discuss today is heating effect of electric current. Heating effect of electric current. So which are the gadgets we used such that due to when the electric current is flowing through that gadget, the conversion is such like that electric to heat energy, electric energy into heat energy, and that is they have been mentioned those things, that these are which are the appliances for that. They have been used water boiler and electric cooker. Water boiler, electric cooker, electric bulb. These are the 3 electrical appliances which is used in our everyday life, in our home. In electrical boiler, water boiler is there. Water boiler will contain a resistor is there. Resistance means we have to use a filament. we have to use a filament, and the filament of a particular alloys or metal. Okay, so water boiler is there. To boil the water, we have to use we have to convert electric energy into heat energy. Electric cooker is there. Electric cooker is there. So on page number 49, we can see the coil of a cooker and coil of a heater. The coil type is coiled coil or a coil or a solenoid coil. Solenoid coil or coiled coil. So that the electrical gadget, such a conversion we can see in that gadget is that electrical energy is converted into heat energy for that purpose. And so these gadgets are a water boiler are there, the conversion of a to raise the temperature of a cold water to hot water, we use the water boiler. After that, electrical cooker is there. Electrical cooker, in that also we can see the filaments which is used to raise the temperature of that coil, and they get whatever we want from that energy. And after that, electrical bulb. And they have already mentioned that the nichrome alloy, nichrome alloy, nickel and chromium, nickel and chromium. So alloy, it is alloy of a nickel and chromium, okay. So nickel and chromium is the alloy, and this alloy can melt this coil, and it is used to water boiler and electrical cooker. But electric bulb, they have used the filament. It is called a tungsten, W. Tungsten, that is W. Its symbol is W, and it used in electrical bulb. So the temperature rises such that they goes up to 3,400 degrees Celsius. At that time, it doesn't melt because the substance used is tungsten. Its melting point is higher than that, so that the temperature goes up to 340 degrees Celsius. And at that time, due to this electric current, it radiates some sort of heated, and due to that it radiates some sort of light is there, and they have been used for that. Okay, so that these are the heating effect of electric current. Another two things we have to discuss today is that we know that we already seen that short circuit is there. Short. So what is meant by short circuit? We have already seen that there are three types of wires. One is live wire. This one is live. Another one is a neutral, and third one is earthing. That is positive, that is negative, and that is earthing, which is used for a PowerPoint section, for an electric gadget fridge is there, and iron is there. At that time we can use the metallic substance which are in contact with that thing. We can use the PowerPoint, and these are the earthing which can be connected with the ground. So that when live wire and neutral wire come in contact, we know that the potential difference between live wire and neutral wire is 220 volt. 220 volt is there. Okay, if the insulation of these two wires, that live wire and neutral wire, due to some reason insulation goes away, and they are in directly contact with each other, live wire and neutral wire, so that there is large amount of electric current is flowing in the circuit. Okay, the large amount of these two wires are insulated. You know that electrical wire that is made of a copper, they are insulated. When these insulations gives away, and due to that they are directly contact with each other, after that large amount of electric current is flowing in the circuit, and due to the amount of that much amount of electric current flowing in the circuit, it is converted into heat. Okay, and so that the substance which is inflammable material which is in contact with this electrical gadgets are catch of fire, and so that it becomes a short circuit, and due to the short circuit we can find out that there are large number of loss due to electrical and if we are not taking precautions about it, and due to the short circuit there is large number of economical loss we can easily see there. So that the short circuit means positive and negative terminal, that means live wire and neutral wire which having a potential difference that much amount of 220 volt, and if they are contact with each other, so that the large amount of current is flowing through the circuit. If electric fuse, what electric fuse candles? Electric fuse is the alloy material which can, if larger amount of electric current is flowing in the circuit with at some critical level, some permissible level, so that this wire F alloy which is connected between it, there is a bridge. This is a bridge, and it is called a fuse. So that in electric circuit, when it is passing through this bridge, that means fuse. So amount of energy, that means amount of current, the amount of it increases so that it melts, and due to melting of it, the circuit breaks, and so that our electrical gadgets can easily survive from that so much accidental things which is happened there. So that is a short circuit. So another thing we have to study today is overloading. Okay, overload, you know that the amount of energy which is we have got from electrical supplier, that our need is more greater than that. If our need is greater than on the energy which is supplied to you, the electric energy which is supplied by MSEB to you, so that in the summer season we can easily see that our refrigerator is going on, switched on, fan is going on, and AC is there, so that the large different bulbs are there, light devices are there.